Alrighty, so yesterday we reviewed surface area, which we've been doing for several lessons now. And today we're actually going to combine both surface area and volume using real world context. So let's look at this problem below. Jay has a small fish tank with an open top that's shown in the picture. He needs to clean the glass and wants to know how much the surface area is of the tank. So, in order to clean the glass, what do we need to know? Well, we need to find out how much glass takes up the entire tank, and so that would be the outside portion of this tank, which would then be the surface area. So we can go ahead and start drawing a net to show all the sides of the tank and just kind of piece it together or break it apart really piece by piece. So I know that if there's a front part of the glass that is 10 inches, well, if that side over there is 11 inches, then this side over here is 11 inches, which means this bottom length 11 inches as well, which would then be the same dimensions as the back piece. So I'm going to write that we have a front and a back piece, so we would double it. And then I also know that if I have this left side over here, in fact, let me use a different color, I see that the dimensions, if it's 10 inches here, then it has to be 10 inches here. And the bottom piece would match whatever it is at the top, which I see on this side, it's 6.5. So this part is 6.5, which means this part is 6.5. And so I can draw that out, that that's 6.5 inches by 10 inches. And there is a left and a right side that match, so we can also double it. And then I also know that we have a tank that sits right on a shape as well. It's not just sitting on an empty space or else the water would leak through. And I see that that piece is 11 inches by 6.5 inches. But because this tank does not have a top, right, I'm actually not going to double it because there's only the one bottom piece. And then I know that if I add all three pieces together, I will get the surface area of the tank. Well, now that I have these shapes broken up, what shapes have we drawn out? Well, they are all rectangles. And so how do we find the area of each rectangle? We use the formula area equals base times height as shown on our star chart. So I'm going to go ahead and write that out. In fact, let me go ahead and break it up so that I know where all of my work is going to be nice and neat. And so now I can start substituting the base and height into those formulas and solving. So I see that this is 11 by 10, which when I multiply would be 110. So the area of one side is 110 squared inches, but because there are two of them, I have to double it. So the area of these two sides are going to be 220 squared inches, and I'll just underline that for the next part. And now the second piece is 6.5 by 10. So when I multiply that, that is 65 for one side. But again, we have two, so we have to double it. So the area of these two is 130 squared inches. And then I have my last piece to find, which is 11 by 6.5. Now this one isn't as easy to do mentally in our head. So let me go ahead and multiply it out really quickly. And so I see that this area is 71.5 squared inches, and there isn't a top piece. So then that is our answer for that side. And now what do we do at the end now that we've calculated all the sides? Well, in order to find the total surface area, we have to add them together. So I'm going to add 220 plus 130 plus 71.5. So let's line up our decimals and our zeros. 5, 12, 3, 4, drop the decimal. So the total surface area that Jay needs to clean is 421.5 squared inches. Because he is cleaning the outside of the tank, we are looking for surface area, and so we're going to practice one more independently.